What about the question of heat buildup? Particularly when we're talking about something like a trillion cells sitting in a three-dimensional arrangement, perhaps in a volume of space that's a few liters, isn't that going to be a lot of heat generation? Isn't that going to be a problem? Well, there's two aspects to this answer to this question. One is that we're not really looking at clocking these cells as quickly as possible. In whatever system we're implementing on this, we don't necessarily need things to be happening in, say, the gigahertz range. The idea is we can have these cells operating relatively slowly, but the entire system throughput can be very high because we're doing so many things in parallel. So the goal is to have, say, a trillion cells operating maybe at 100 hertz each, but we get a lot of throughput because we have all these cells acting at the same time. So we try to leverage the parallelism aspect as opposed to the individual processor speed aspect in order to get a high performance out of the system without necessarily generating a lot of heat. The other aspect of the answer is that it depends on your manufacturing. And again, we're not going to be able to manufacture a trillion cells using today's transistors, using silicon gates, and so on. We're going to have to find some different kind of technology, and the hope is that when we're developing new technologies, we're going to find things that are going to operate cooler. They probably won't operate as fast. Chemical processes aren't going to operate billions of times per second, but they're not going to generate as much heat either necessarily. So the goal is to have some kind of technology that is scalable that we can use to manufacture these cells and hopefully pay a price where we don't get as high a performance out of the individual elements, but we can tile a lot of them without worrying about heat and then leverage the parallelism.